In this video, I want to show you how to start analyzing football data with the goal to build a model to predict football results. We will start completely from scratch, and by the end of the video, we will have a dataset of Premier League match statistics, and we are going to extract some insights from it. The first thing that you need to do is to install the right tools. For the job, the best tool is Python, and the easiest way to use it is via the Anaconda distribution. And this is extremely easy to set up even for beginners. So let's go through it. To get Anaconda, you just need to navigate to this link that I will show you now. You'll have to download the graphical installer for Python 3.7 and your platform. In my case, it's a Mac. They will ask you to provide an email to download the distribution, but you can just skip the registration. Now you need to choose here. In this case, the distribution available is for Python 3.12, which is one of the latest versions. You can decide to download the one for Windows, for Mac, for Linux, depending on your distributions. In my case, it's for Mac. This is a 700 megabyte package, so it might take some time to download depending on your internet connection. Once you have downloaded the package, you just install it following the instructions. The installation process should take around 5 minutes or so. Once you have installed Anaconda, you can create the so-called notebooks. The notebooks are research environments that let you combine code, graphs, text in your web browser. In this way, you can load the data, manipulate them, visualize the results, all of it without leaving the browser. And it's very convenient, of course. I suggest you create a folder in your PC and call it football_research. You will operate in this folder and you'll save everything you need there. Inside this folder, create 3 subfolders. One that is called notebooks, one that is called scripts, and one that is called data. In notebooks, we'll put all the research code. In data, we will just put the data that we will read through our notebooks. And in scripts, we will use them to either update the data or update the model or upload a new version of the model. Some Python code will live there that will automatically, whenever we run it, download a new version of the data or a new version of the model. Now it's time to create the first notebook. To do that, you just open Anaconda Navigator. And here you should see this screen. So it's basically a list of cards that belong to the app. The first card is called Jupyter Lab, and this is the one that we will use for the development of the model. You just click on Launch, and this will open a new window in your browser. So navigate to the Football Research directory, the directory that you have just created in the previous step. And now you can create a new notebook. Go inside Notebook and create a new notebook by clicking on the Python 3 icon. The new notebook is named as Untitled.ipynb. So one of the first things to do is usually to change its name, because this is the default name of every new notebook. We'll change its name to getdata.ipynb. Rename notebook 1-get-data.ypynb. I usually use this naming convention so that once all the notebooks will be shown here on the left bar, they will be shown in order from the first to the second to the third, and so on and so forth. The first step is to actually get the data as we have named our notebook. The data is essential for any model, and the more you can get your hands on, the better your model will be in general. For our purpose, we're going to use the data available at football-data.co.uk. This is a nice historical series that covers all the major European leagues. This website shows various different games and features different data for different games. Is focused on betting and especially on football betting or soccer betting, but not only. There are bet calculators, some betting articles. What we're interested in are the main leagues sections and especially the latest results from the main league sections. If you click on one of these main leagues, let's say for example England, you will have the English Premier League results for the season since 2000, let's scroll, 2006-7, and it goes back to 2001, 2002, and so on and so forth. We will not use the seasons earlier than 1999-2000 because they only contain full-time and half-time results. We will use everything that goes from 2000 to the latest 2023 because they have both the full-time and half-time results as they've both the full-time and half-time results and also the match stats and the match odds that will be interesting to compare the results of our model with the odds at the time of that the match was played. So let's see how to automatically get our hands on these data and then start to first of all understand what's inside there, second of all visualize them, and then finally start to build the model and test it and create predictions for the current Premier League season. So it's quite simple. You just navigate to the notebook. In the first cell you need to import the library, Python library that you will use to both download the data and structure them in a way that we can actually then visualize and build the model. So this library is pandas, and we will just use the usual default way of importing pandas. We will import pandas SPD. In this way, every time that we need to use a method from pandas, we can just call pd dot and the method that we want to use. Another thing that you want to do immediately after that is to set the maximum columns of a pandas data frame, which you can think about as a table, literally with rows and columns, and we will set the maximum columns to display to a very large number so that we will be able to see everything that is in the data that we will download from footballdata.co.uk. To do that, we type, as you've seen, pd.set_option, and the option that we want to set is the display.max_column, and the value that we want to assign to this option is something large, let's say 80. We now so what this will do, it will load all the tools that we need to read and to create local representation of them in our computing environment with pandas, and also we will modify the setting to show all the possible rows in our dataset. To execute this cell, we can do two things. Either we press the play button here, and you will see how the cell is executing because there will be an asterisk between the two square brackets. Another way to execute the cell is to simply press the Shift-Enter combination, and it's much handy to do this. Okay, as you see, we have imported the pandas library and we have set the number of columns to display to a very large number, 80. The next step is to actually import our data. Let's import, for example, the data from the latest season, 2023-2024. In the cell that we have just created, we can write the F, that stands for data frame, equal pd.read_csv, and here we'll put the link of the latest data from the Premier League 2023-2024. How do we find this link? We will just go back to football data, to the football data page, and here is the Excel file or CSV file, and you can see it on the bottom left, the name of the CSV file. Once you hover with your mouse over it, you should see it on the bottom left of your browser. Simply make a right click on the link and you will see copy link address in the options. We just copy the link address and then we paste it in our notebook. As you see, it has HTTPS, then the domain name, some kind of code, 23-24, which is the season, and then E0, which is the code for the Premier League. For example, the Serie A should have I0 as code, the Bundesliga should have B1, and so on and so forth. But we will see that later when we will analyze the data from the Bundesliga. Execute the cell again with Shift-Enter. And in this way, we will load all the data that is into this CSV file into an object which is called a DF, which is a data frame, which you can think of as a big table. Let's visualize this big table. To visualize the first 5 rows of the table, we just invoke the method df.head, and between the parentheses the number of rows that we want to visualize, in this case 5. And you will see that here we have 5 rows, right? Each of them has the code for the league, E0, Premier League. We are not much interested in that, but then we have also the date, the time of the match, the home team Burnley, the away team Man City, for example, and a lot of data about this match. You can recognize many of them, like for example the first ones, full-time home goal, full-time away goal 0-3, full-time results A, which means away. There are 3 possible results: H, A, or D. H being home, A being away win, or D being the draw. And also the results at halftime, the goals scored at halftime, the name of the referee, the shots of the home team, the shots of the away team, the shots on target of the home team and of the away team, and so on and so forth. We will dive deep into this when we will build our model. So the dataset has a lot of columns, and also has a lot of information related to the betting odds for different bookmakers. This is good from one side, but also a little bit creates a little bit of confusion on the other side. So let's just a bit limit ourselves to a few only match-related information. For example, we only want statistics related to the match, to the shots on target, and in general offensive production of the team. So to do that, we can define a new data frame, which we will call df_clean, which will have less columns than the previous one, and we will specify here between square brackets a list of columns that we are interested in. We can do something like that. First of all, we define the list of columns, and we will call it cols. And this will be a comma-separated list of strings, which will have the name of the columns that we want to retain. In this case, we want to retain the home team, the away team, and a few interesting statistics, like surely the full-time home goals, the full-time away goals, which I'm copy-pasting from the original data frame just to be sure. We also want the full-time result, we want the home and away shots, the home away shots on target, shots, away shots, home shots on target, and away shots on target. And since we're here, we also want the corners, home corners and away corners. You see there is a lot more information, but we're not really interested in it. For example, the fouls or the yellow and the red cards. Now, to just select these columns, we will call df_clean. We will define a new data frame df_clean, and we will assign it the value of df, and between square brackets we specify the calls. Again, we have executed the cell with a shift enter, and now we can visualize df_clean first 5 rows as we have done before, df_clean.head 5. And here you see that we have exactly the same 5 rows as before, but many fewer columns, which makes it easier for us to manipulate. Let's save this data now. The step to save this data is just to call df_clean and invoke the method to_CSV. So as read underscore CSV was the method used to read a CSV. You can read it from local or from the internet. Here to_CSV saves the data in local. Since we have data directory, we will save directly there. // tells it to save it in the previous directory, football research, and then go back. So go back in the football research directory and then save it in the data directory inside there, and we will call it EPL underscore 2324 underscore clean dot CSV. And now if you go into football research data, you should see that there is a new file created called EPL underscore 2324 clean.csv, which is has been modified seconds ago when we last created it. This is all you need to do to be able to collect the data from the internet, manipulate it a bit, like reduce the number of columns in our case, and save it in local for faster and more efficient data analysis. So the next step is to visualize our data. In order to build a reliable model starting from match data, it's important to understand what those data look like. Simply extracting some statistical properties out of the dataset is not enough. So data visualization is essential to discover already correlations and build some intuitions on our future model. So let's create first a second notebook where we're going to explore the data, create some nice plots that will help us understand the data features and which are the most important ones to look into. Again, to create a new notebook, we can just go on the left bar in the Jupyter Lab and click on the plus icon. And now we will create a Python 3 notebook. We will create a new notebook, and this we will name it Visualize Data. Again, rename. We will follow the same convention of creating a new notebook with a sequential number. So this will be called to-visualize-data.ipynb. So in order to read the data from the file that we have saved in the previous chapter and also create some plots, we'll need to import the right Python packages. First of all, the pandas package that we've imported before. Import pandas as pd. we'll need to import new packages in every new instance of notebooks because each notebook is a separated research environment and will need to be set up separately. So the notebooks do not communicate between each other. We will import matplotlib to visualize the data. And to do that, we will import matplotlib by plot as plt. We will also import matplotlib as MPL. And then we will set up matplotlib parameters to make the graphics a little bit more appealing. So we will do MPL RC params, and we will specify which parameter we want to change. In this case, axis.grid be set to true with capital T. This will be essential to create plots where we will also see horizontal and vertical axes in it to guide a little bit our eye on how to interpret that plot. We will also remove the spines from the top and right of the plot, and we will do the same thing. Here I just copy paste a few commands, but MPL RC params. Now we want to remove the top spine. We call axis.spines.top, and we will set it to false. Axis.spines.right. Also, we want to set it to false. And also, we want to increase the default label size of the X and Y ticks, just to make a bit more evident what are the numbers that we are looking at. So, xticks, to do this, xticks.label size with no capital S. We'll set it to 20, and we will set the yticks label size to 22. Okay, so this should be all the setup that we need to do. Keep the grids in the plots, take away the spines of the plot from the top and the right frame, and increase a little bit to 20 pixels the font for the X and Y ticks labels. Okay, in this case, xtick and ytick label size 20, and let's try. Okay, perfect. Now, let's explore the data frame that we have just saved in the data directory by executing the usual two commands. We will read the data frame, and then we will show the first 5 rows. The F EPL, we will call this data frame, will be pd.read_csv, what we have created before. It should be in the data slash, should be called EPL 2324 clean.csv, and then the F_EPL dot head 5 to show the first 5 rows. And as you see, we have the usual Burnley City, Arsenal, Forest, the results, the 0-3, 2-1, 1-1, and so on and so forth. The full-time results, home or away or draw. Home shots, away shots, home shots on target, away shots on target, home corner and away corners. Let's. This is just the first 5 rows, but for example, if we look at the last bottom 5 rows, the FEPL, as you can imagine, head and tail 5, we will see the last 5 rows. And you will see that these are the 379 to 380 row, represents the 380 match played in the Premier League 23-24, which was Sheffield United Tottenham in this case. Final result 0-3, away win with 6 home shots and 18 away shots. So you can see that from exploring the data, this dataset contains 380 matches of all the football that has been played in the Premier League in 2023-2024 by all the teams. If we want to focus only on one team, let's say focus on one team, this what I've just done is, by the way, a comment. The comment starts with the character hashtag, and if you focus on one team, let's say that we want to focus on Manchester United, right? The best way to do it is to select only the rows of df_EPL that contain Manchester United, either in the home team column or in the away team column. So if we take the FEPL to do that, we can just select the FEPL, open square brackets, and between the square brackets, again the FEPL, where home team is exactly equal to Man United, which is what the team is called in this dataset. If we do that, we will see only the home matches of Manchester United. So all the probably 19 matches that Manchester United has played in the 2023-2024 campaign. And if we do, instead of home team, away team, we will only visualize the away matches that Manchester United has played in 2023-2024. To visualize both, we can employ this trick. We'll take the first condition between parentheses and then combine it with an and, with an or, logical or, of all the away matches that Manchester United has played in the 2023-2024 season. This is basically telling to take all these matches where Manchester United was either one of the home team or one of the away team. If we execute, we will see that we have all the Manchester United matches, including both home and away. So let's have a look, for example, at the shots. A good starting point for the analysis in general is to look at one of the basic attacking outputs of every team. So look at the shot made by the team and how they correlate with the number of goals scored. Here we have both the goals scored, the number of shots on target. Let's create, to do that, first of all, the first step is to enrich the data. So we will create 2 new columns in the data frame called shots and goals. And this will represent all the shots taken by Manchester United in a single match. First of all, we like to create the data frame of Manchester United, and we can just modify a little bit the cell just to assign the results of this selection to a new data frame, which is called df_Man United. Now df_Man United has been saved in a new separate data frame, which we can visualize here. So what we said before, we want to create 2 new columns in this data frame, which is the number of shots and the number of goals taken by Man United in a single set, in a single match. you can argue, we already have this information in our data frame. Yes, but it's split into two columns. So for example, for the home team, home matches, we have the information in the FT of the goals that Man United scored in FTHG. But for the second match where Man United lost 2-0 against Spurs, we have it in the second column. So we need to find a way to aggregate this data in one single column. And to do that, we just create a new column, which we will call goals, which will be goals. And to do that, we will apply a function to each of the single rows of this data frame. So how to do that? How to do that? We call the apply method, and inside the apply method, we call a so-called lambda function, which will be a simple function that returns the FTHG value if Man United is the home team, and the FTAG value if Man United is the away team. So it will be lambda x, and it will be x, where x is the row of the data frame, and will be x FTHG if x home team is Man United, equal Man United, else x FTAG in case the away team is not the away team is Man United. So if Man United is not the home team, it's definitely the away team. So we don't need to specify a new condition here, and we will specify axis equal 1 to tell that these functions will be applied on the columns. Similarly, we will calculate the shots that Man United has taken and save them in a new column, simply by checking if Man United was the home team, getting home shots, and if Man United was the away team, saving away shots. We can copy paste the code above and change only goals into shots, FTHG into FT into H S home shots, and FTAG into AS away shots. Execute. There will be a warning. This warning shouldn't worry you at all, but if you really want to get rid of it, you can try to use .lock and apply this the same function here. For example, we will just do, instead of the F Man United goals, we will have the F Man United dot lock, okay, row indexer 2 dots, comma, goals, and we will not have the error again. Now we're ready to visualize the features that we have just created. Now we can make a two-dimensional scatter plot to show how the number of shots made is correlated with the number of goals scored. This we will do it here in the new cell of the notebook. Just call it visualization. The first step is to create the fig and the ax, which are the container of our plot. plt.subplots, and we will specify the figure size. Fig size equal size equal, I will make a square 8 by 8. The next step is to tell which kind of plot we want to make. We will make a scatter plot, plt.scatter, And on the X, we will specify the shots, the F_Man_United shots. On the Y-axis, we will specify the goals, the F_Man United dot goals. We want to specify also the size of these dots. Let's make it bigger. And the opacity, which is controlled by the alpha factor. We can make opacity 0.5. This is because most of the dots will overlap, because in many matches Man United will have scored the same amount of goals, but with different amount of shots. So we will just specify alpha, and we'll see less overlap between those dots. And finally, let's specify a color. I will take a color from it's HTML, it's a X color code. Should be something like a red or a green, something like that. We can just specify red. Finally, we will set the labels of the axis, and we will set the font size, and we will show the plot. So to set the label, we just code AX set underscore Y label, and we will call it goals, and we will specify the font size of the label, which should be something like 30. Same thing for the X label. We will just X label, we will label it shots, and we will leave the font size at 30. Finally, we can show the plot by calling plt.show. Executing this cell will create a beautiful plot of all the goals that have been versus the shots that have been made by Manchester United in the 2023-2024 season. For each match played by Man United, you will have the number of shots taken on the x-axis and the number of goals scored in a match in the y-axis. For example, sometimes it's not enough for Manchester United to score, even if they shoot 20, 23, 20, 22, 23 times, and sometimes scoring 2-3 goals takes on less than 10 shots. If you want to know more, visit my Gumroad page and have a look at my books on how to build a soccer model in a weekend, soccer betting coding for advanced concepts, and build a football betting model for Euro 2024. I hope you enjoyed this video. Stay tuned for more.